Okay, let's turn next to 53, and so here we need to calculate the covariance for the above data, and we have a scatter plot. Maybe I can make it a little bit smaller so it fits on the screen. Okay, so we need to feed the covariance, standard deviation, and y, and I think we should also calculate the correlation coefficient. Okay. Okay, so also compute the correlation coefficient. Okay, let's first get an idea of what the data looks like. So we have x's and y. So there's a 2 and a 5, so that would be this observation here. Then we have a 12 and an 8. So 12, that seems to be here. Then we have a 3 and an 18, that's here. Then we have a 6 and a 20. That is here. 1, 2, 3, 4, 5, 6. Then we have an 11 and a 22. 11 and 22. That would be here. Then we have 19 and 30. Okay, so that's easy, that's there. Then we have 18 and 10. That would be here. And a 9 and a 7. 9 is here. Okay, so here's our x-axis, of course, and here's the y-axis. Okay, so I don't know, but the line of best fit would maybe look something like this. But anyhow, we are not supposed to calculate a regression line, something we will do later, but a covariance. The reason why we drew this one is so that we know there should be definitely a positive covariance. So the formula for the covariance is, again, I just write it here, covariance x and y is the sum of the products of all the deviations from the mean divided by n minus 1. Okay, so how many observations do we have? 1, 2, 3, 4, 5, 6, 7, 8. So our n is 8. And so we have 8 dots. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So maybe I'll just expand this column here. Well, maybe that was a bad idea. So let's just make a column here again with x. So we need the x's again. Then the xi's, then the yi's, okay, so here we had 12, 2. Let's try to x, y, then we have, okay, so here we have the 2, 12, 3, 6, 11, 19, 18, 9, here we had 5, 8, 18, 20, 22, 30, 10, 7. Okay, so in the first step what we need to do is we calculate xi minus x bar. And so we need to calculate the mean for x. So x bar is 2, 14, 17, 23, 24, 34, 43, 53, 53, 61, 71, 9, 80. 80 divided by 8 is 10. Y bar 5, 13, 21, 31, 51, 53, 73, 103, 1013, 1020. 120 divided by 8 is 15. Okay, so now for x we subtract everything from, we subtract from each observation the mean of 10. So 2 minus 10, negative 8. 12 minus 10, positive 2. 3 minus 10, negative 7. 6 minus 10, negative 4. 11 minus 10, 1. 19 minus 10, 9. 18 minus 10, 8. 9 minus 10, negative 1. Okay, so now let's do the same thing for y. So 5 minus 15, negative 10. 8 minus 15, negative 7. 18 minus 15, positive 3. 4 minus 15, negative 11. You gotta be careful with the number. So 5 minus 15 is 10. 8 minus 15, negative, but here 20 minus 10. 20 minus 15, that's 5. I looked up the wrong column. So 20 minus 15, 5. 22 minus 15, 7. 30 minus 15, 15. 10 minus 15, negative 5. 7 minus 15, negative 8. Okay, so now we can calculate next the product of these. So xi minus x bar times yi minus y bar. Okay, I hope I didn't make a mistake. Negative 8 times negative 10 is 80. 2 times negative 7 is negative 14. Negative 7 times 3, negative 21. Negative 4 times 5, negative 20. 1 times 7, 7. 9 times 15, 135. 8 times negative 4, negative 40. Negative 1 times negative 8, 8. And now I just need the calculator here. Okay, so what's the sum? Okay, so that is 80 minus 14 minus 21 minus 20 plus 7 plus 135 minus 40 plus 8. So unless I made a mistake, the sum is 135. So here in the numerator we have 135, and now we need to divide by 7, and if we do that, I get something like 19.286. 19.286. So it's a positive value indicating that there is a positive relationship. So next we need to calculate the standard deviation for x and y. Let's first calculate the standard deviation for x, and the formula is the sum and then the square root. Okay, so we have xi minus x bar, so I can square that. Minus 8 is 64 plus 4 plus 49 plus 16 plus 1 plus 81 plus 64 plus 1. Okay, so let's calculate this one. (64) plus 4 plus 49 plus 16 plus 1 plus 81 plus 64 plus 1 equals to 80. So and then we have to divide by 7. So we have 280 over 7, which is 40. So the answer is okay, so now let's calculate the standard deviation for y. So we just need to replace the x by the y, so I'll just skip that. So here we have now in the numerator 100 plus 49 plus 9 plus 25 plus 49 plus 225 plus 25 plus 64. Okay, so let's calculate this one here. So 100 plus 49 plus 9 plus 25 plus 49 plus 225 plus 25 plus 64 equals 546. Divided by 7, so six divided by 7 is 78. Okay, so now we should be able to calculate the correlation coefficient, which is simply the, let's do that here, so the correlation coefficient would be the ratio of the covariance between x and y over the product of Sx times Sy, which is 19.286 divided by the square root of 40 times the square root of 78. Okay, so let's see what that is. 19.286 divided by the square root of 40 times the square root of 78. And then I get something like 0.345. That suggests a rather weak correlation. And you can see from the scatter plot, yeah, well, it is positive, but the dots are really very far spread around. So what I still want to do is I just want to double check using Excel. So let's open an Excel file, and let's copy this data. Okay. So this was our data. So let's insert a column here. Let's calculate the mean first for each one. It's actually the one down below. The mean is equal to the average. 10, we can copy that to the right, 15, so that was correct. Now the standard deviation equals standard deviation 6.3. Okay, so that was, in our case, the square root of 40 and the square root of 78. Let's just double check if that's the same. Square root of 40, yeah, and the square root of 78. Okay, so we got the same. Then the covariance. So we use the formula covariance.s, and then we are asked to identify the first array, comma, second array, and here we got something with 19. So 19.285. I think that's the same that we got. 19.28 if we rounded 6, correct? And then the correlation coefficient should be also correct. So coefficient. So the command in Excel is correl. And we have array 1, comma, array 2. And now we should get something like 0.345, which is exactly what we got. So it looks like we didn't make a mistake, which is good. And in the next video, we just jump right into Excel and work with a more real-world data set and omit any manual calculations and just use Excel. So I'll just stop here.